This is the first trinomial we're going to factor. One thing to notice about this trinomial that's important is that the leading coefficient here is 1, as it will be in all these trinomials. So look for the leading coefficient 1. Remember, all that means is a number in front of the x squared term. Now, in order to factor this trinomial, what we're going to have to do is play a little number game. We're going to look at this number, the third entry here in the coefficient, the constant term 12, and we're going to think of all the factors of 12 that we can think of. Let's write those down. 12 could be 1 times 12. 12 can also be 2 times 6. And 12 can also be 3 times 4. Now, those are all the factors of 12. In this little number game that we're going to play, we're going to look for the factor of 12 that have the sum of the middle term. In this case, that's 8. So you have to ask yourself this question: what numbers have factors of 12, but what are the factors of 12 that have a sum of 8? Factors of 12, sum 8. Well, here we go. 1 plus 12 equals 13. 2 plus 6, there it is, 8. So what that tells me, the 2 and the 6 are the numbers we're going to use in the factorization of our first trinomial. So we'll set it up this way. Now the easy part about this particular factoring is that since this leading coefficient is 1 on the first term, these first two numbers have to have a product of x squared. There's only one choice. It would have to be x and x. Now we've already done the difficult part in that we found the two numbers that have a product of 12 and a sum of 8. So what we're going to do is put them in like that, R2 and 6. Again, product 12, sum 8. And that's all you have to do. Now to check to make sure that you did this work correctly, all we have to do here is to use the foiling method. So you can check and you can be assured that your factoring is correct by taking 1 extra minute to check to make sure that this product equals the original trinomial. So let's try that. Remember FOIL, first, x squared, outside, 6x, inside, 2x, and last, 12. Add like terms in the middle here. We get x squared plus 8x plus 12, which is where we started. So we factored correctly. Let's try a second problem. Now the difference between this first problem and the second problem is that in this one here we have a product of positive 18, and now we're looking for a sum of negative 11. Let's get started here by doing the easy part first, and that is putting the x in. Remember, x times x gives us that first term. Nothing much to think about. So here we go. Again, what we're going to do is list all the products of all the numbers that have a product of 18 but a sum of negative 11. So let's start. 1 times 18. Now, since we want to have a positive product but a negative sum, let's think about multiplying signed numbers. If one of these is negative, then I'll have a negative product. I don't want a negative product, I want a positive product. So if I make both of these negative, that's going to give me a positive product but a negative sum. In other words, if I multiply these two numbers together, I'll get positive 18, but if I add those two numbers together, I get a negative 19. Now, those two numbers didn't work, did they? Because we're looking for the sum of negative 11. So let's move on. Let's try another pair. How about a negative 2 and a negative 9? Negative 2 times negative 9 certainly gives us that positive 18. Now let's check the sum. If I add those two numbers together, negative 2 plus negative 9, notice I get a negative 11 there. And that's exactly what I wanted. So these are the two numbers I'm going to use in my parentheses, -2 and -9. Now again, if you're not sure of yourself, all you have to do is make a quick check by applying the FOIL method to these two binomials. First, x squared. Outside, -9x. Inside, -2x. And last, +18. You should be getting pretty good at foiling now. Let's add those middle terms. X squared minus 11x plus 18. A perfect match. So we know that our factorization is accurate. Let's try one more. A squared minus 5a minus 24. Now, again, we've got some different signs here, so we're going to have to think a little bit. We want a negative product and a negative sum. We have to think of two numbers that have a product of a negative and add up to a negative. So let's think about this. First of all, let's look at 24. Factors of 24. How about 2 and 12? Now, if I'm going to use 2 and 12, remember we want a negative product. So in order to get a negative product, we need one negative sign. We could put the negative sign here with the 2 or with the 12. Now notice one thing about this, it creates many more possibilities because -2 and +12 give me +10. Also, I could switch the signs and make this a -12, which still has the same product of -24, but this time my sum is a -10. So once you find factors of 24, not only do you have to check a negative times a positive, but you have to switch the signs on each number because they have different sums here. So this is a little trickier. We have to play with numbers a little bit more. So obviously this one didn't work because we needed two numbers that have a product of -24, which these do, but at the same time we want them to have a sum of -5, which in this case we got 10 and -10, so that doesn't work. Now, the more you do this, the easier it will become. So let's think to ourselves again. What two numbers have a product of 24? Now think product 24, but at the same time you want some kind of difference of -5. How about 8 and 3? Now again, one of these has to be negative because we want this -24 product, and at the same time we want a -5. So keeping that in mind, knowing that we want to have a negative sum, what we're going to do is put the negative sign with the larger number. In this case, that's going to be -8, because -8 times +3 is -24, and -8 plus 3 gives us a -5, which matches what we want here. So again, to complete this factorization, what we're going to do, the easy part, drop in the a's. We found here that the two numbers that work in this particular case are -8 and +3, product -24, sum -5. Now it doesn't matter which way we put these in. I can write this as a minus 8 times a plus 3, or I could have put here a plus 3, a minus 8. I could switch these around, and it will not make a difference because remember, again, multiplication is commutative. This one times this one is this one times this one. We've talked about that before. Okay, so again, just take a moment at the end to make a quick check by applying FOIL to your binomials. So here we go. F, a squared, and this should be almost second nature to you now, plus outside 3a, plus inside minus 8a, and last we have -24 because we have -8 times +3. Add the two inside terms. That gives us a squared minus 5a minus 24. Make a quick check. It's exactly where we started, so we can be assured that a minus 8 times a plus 3 is the correct factorization for a squared minus 5a minus 24. Now what I want you to keep in mind as you work through this section is this method only works for trinomials when the leading coefficient is 1. Notice 1, 1, 1. So that's your first check. And again, when both signs are positive, you don't have a sign problem, so it's easy to find product 12, sum 8. As these signs change, you're going to have to do a little bit of thinking. When the sign here is positive and this one's negative, you know that the two numbers have to be negative because a negative times a negative is a positive, but when we add them together, we get that negative sum. When the signs are in this fashion, you have more choices. We need a positive and a negative, we know, to get that negative sum. But here you have to make sure that you put the negative with the correct number so you get the sum that you're looking for there. Now, don't feel discouraged. At first, it's difficult for most students. The more you practice, the easier it will become. Let's take a look at factoring some other trinomials. We're going to factor this one, 4x squared minus 8x minus 140. Now, one of the things about factoring that I want you to keep in mind is this. Whenever you factor, no matter how many terms there are, always think of the GCF, the greatest common factor, first. Check to see if there's any number that divides evenly into the numbers you're given. So in this case, I see a 4, 8, and 140. What number divides into all those three evenly? The number 4. So we're going to factor that out first. So here we go with our 4. Then inside we have x squared minus 4 times negative 2 gives me 8x. And finally, 4 times negative 35 gives me 140. All right, now that we've done that, this should look very familiar to you. Now we're back to factoring trinomials of the form x squared plus bx plus c. In this case, our b is negative 2 and c is negative 35. So what we're going to do then, remember we learned this, is we know it's going to factor in this fashion. The first terms, there's no thinking. We know that we have to have an x and an x to get x squared. That part's easy. Now the more difficult portion. We need to think of two numbers that have a product of negative 35, but at the same time have a sum of negative 2. So think of it. Negative 35, negative 2 sum. Did you come up with 7 and 5? At least we know that 7 and 5 are 35, but here we go with the negative and the positive to give us negative 35, negative 2, and we're done. Now go ahead and use the distributive property to check it on your own, and you'll see that we were correct.